Okay, today we're going to be talking about modeling linear functions. So that's page 29 in your packet, and please write your name at the top. Okay, so modeling linear functions simply means relating linear functions and graphs of lines to real-life situations. So we've talked about slope. We've talked about slope, and we've talked about how the slope relates to real-life rates of change. So some examples of that would be miles per hour. Briefly, the independent variable is your x value. So we want to make sure that we know that. So let's get that in here. Independent equals x and dependent equals y. Okay, so let's just put an x here above independent. Using these quantities, slope and y-intercept, we can model and solve many real-life problems. Exercise 1. The Arlington freshman class wants to have a fundraiser. The class wants to buy a number of $4 flip-flops and $5 bracelets. The class has a total of $100 to spend. A pair of flip-flops is $4 and each bracelet is $5. So if x represents the number of flip-flops and y represents the number of bracelets, complete the table below. Okay, so the number of flip-flops in this case is 0. So how much are we going to spend on flip-flops out of the 100? 0, which leaves us $100, $0, and this is $100 left for the number for bracelets. The question is, how many bracelets can we buy for $100? Y is number of bracelets. We have $100, and each one is $5. So divide by 5, and you get 20. You can buy 20 bracelets for $100. We're going to buy bracelets now. Or actually, we're not. We're going to spend $0 on bracelets, which means we have $100 to spend on flip-flops. And if we have $100 to spend on flip-flops, then the number of flip-flops, x, that we can buy is 100 divided by $4 equals 25. So we can buy 25 pairs of flip-flops when we buy no bracelets. All right, let's jump to part B. Using the 2 points from part A. Wait, oh, look at that. That's an xy pair. xy is 0, 20. So, and I guess they said 2, so we must have 2. xy is 25, 0, 0. Okay, so using the 2 points from part A, write a linear equation. Whoa, wait, in y equals mx plus b form, I have to stop again. M equals b equals x equals y equals. Okay. Write a linear equation in y equals mx plus b form that gives the number of bracelets is y, that can be bought as a function of the number of flip-flops that can be bought. Flip-flops is x equation. So we start with m and b. We need our m and our b. This is a review from a couple of lessons ago. We don't have an m. We don't have a b. We have xy, 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 xy. y2 minus y1. M equals y2 minus y1 over x2 minus x1 will give us our m. So if I just bridge these, like those are my y's, those are my x's. See how the y's are on top? That's going to help you remember that. That's going to be negative 4 over 5. And we've talked about that negative. It can go right in the middle, on the top, on the bottom. It doesn't matter. There, we have an m. We don't have a b. We have an x and a y. Oh, we have an x and a y. 0, 20. Could I use 25, 0? Sure, but I can barely read that, so I'm not going to. Okay, so now if I have 3 out of my 4 variables, I can get the fourth. So it's going to be y equals m plus b. Y equals mx plus b. And I have a 20 for y. Substitution is the name of the game here. Negative 4 over 5. My x value is a 0, and my b value is a, well, I don't know. But I only have one variable, therefore I can find out what b is. 0 times negative 4.5 is 0. And 0 plus b is b. And b is equal to 20. And look at that. Now we have a b value. Okay, so there's my b. There's my m. I'm good to go. Y equals, I fill in an m, negative 4 over 5 x, and I fill in a b, plus 20. And there you have the equation of the line that gives the number of bracelets that can be bought as a function of the number of flip-flops that can be bought. C. Using your equation from B, determine the number of bracelets that can be bought if 10 flip-flops were purchased. Okay, using your equation from B, so let's rewrite that. That's y equals negative 4 over 5x plus 20. Determine the number of bracelets. So we're going to find the number of bracelets. So our answer is going to be something, bracelets. And that's y. We're looking for y. That can be bought if 10 flip-flops were purchased. Okay, flip-flops was x, so we're using x equals 10. This is substitution, just like 90% of algebra. Okay, so y is what we're looking for. Negative 4/5. The variable that we're replacing or substituting in is x, 10 for x. And there we go. Now, we can just throw that in our calculator, or you can do it by hand. Y equals 12. Well, what does y represent? The number of bracelets. 12 bracelets. Exercise 2. From 2000 to 2007, the number of coffee shops in a certain country increased by 100 shops per year. In 2002, there were 1,100 coffee shops. Write a linear equation for the number of shops, y, as a function of time, t, where t equals 0 represents the year 2000. Wow. Okay, we need to break this down. Okay, I see, write the linear equation. Write a linear equation. I know I have to get an m equals and a b equals, and I might need an x equals and a y equals. Okay, let's just box the m and the b to make sure we know that that's what's going into our equation. Okay, write a linear equation for the number of coffee shops, y. Number of coffee shops is going to be y as a function of time. Okay, well, time is t. We usually use x. So for now, let's just change this to an x. So time is x. Where t equals 0, let's just change it to x equals 0, represents the year 2000. Okay? All right, so let's see what we have from above here. From 2000 to 2007, so from x equals 0 to x equals 7, the number of coffee shops was y in a certain country increased by 100 shops per year. Increased, so it changed, it went up by 100 shops per year. Wait, that's rate, 100 per year. Rate of change, that's m. Rate of change is your slope. Slope is rate of change, so m equals 100. In 2002, x equals 2. There were 1,100 coffee shops. 1,100 coffee shops is y, the number of coffee shops. Okay. They asked us to write an equation of the line. So y equals mx plus b, where we're going to have to fill in an m and a b, but let's see what we have to fill in now. We have an m value, okay? And there's my m. So there's my m. So I'm going to put 100 in for that. I do not have a y-intercept. Move on from that. Do I have an x and a y? I have an x and a y pair. Look, in 2002, there were 1,100 coffee shops. That's actually the point, 2 comma 1,100. It's when x equals 2, y equals 1,100. Okay, so I have my x, my y. Oops, I'm having trouble with that number, 1,100. So now I can go into finding my B value. So Y is 1,100 equals M, which is 100, X, which is a 2, plus B, which is an, I don't know, but I know 100 times 2 is 200, plus B equals 1100. I'm going to subtract 200 from both sides, and I will get 900 equals B. I have my B value, I have my M value, and so now Y equals 100 X plus 900. That is the linear equation that represents the number of coffee shops Y as a function of time. Part B. Based on your linear model from Part A, predict the number of coffee shops that will be in the country in 2025. Okay, linear model is just your equation that you wrote. Our linear model is Y equals 100x plus 900. And it's asking us to predict the number of coffee shops, that's Y, that will be in that country in the year 2025. That's X. Okay? Well, that's X equals 25. So, Y equals, this is substitution, 25 plus 900. And you just do calculations, that's a 5. And you get 3,400. Y equals 3,400. Well, what does that mean? That means that there will be 3,400 coffee shops in that country in the year 2025, based on this linear model. Number 3, the cost to subscribe to an online internet service consists of a $15 per month flat fee and a $4 per hour additional charge fee. And there we go. Okay, so let's see what we have here. They're asking us to create a linear model. Linear means line. Model just means equation. So a linear equation. That's your Y equals MX plus B. So we need an M equals, a B equals, maybe an X, maybe a Y, but for sure these two. If you watch the internet 0 hours, you are being charged $15. Look at that. That's your XY. Now, if I plot 0, 15, I end up on the y-axis. That's my y-intercept. So B equals 15. This guy here, $4 per hour, that's my rate of change. For every hour, I get charged $4. That's my slope. And therefore, I can write the equation of the line, y equals 4x plus 15. Part B, using your calculator to generate a table of values, graph the model you formed in Part A on the grid provided. Okay, so we're going to use our calculator, y equals, and when they talk about the model, they're talking about this guy here, okay? It's just the equation. A model is an equation that represents a situation. Okay, so it's 4x plus 15. And I'm going to need a table, so that's second graph. And my table right now is at 5. I want to start at 0. So 119, not graphing it. Why? Because it's 19. It's not easy to graph. These are going up by 5s. I don't have to graph every single point. 535, that's easy. Okay, that one was easy enough. Let's see. Maybe I'll do one more. Use your straight edge. And they're asking us now, in Part C, Lucy was charged $75 after signing up and using the service for 1 month. How many hours did she use? Justify your answer both algebraically and graphically. The charges are the y-axis. So if I go to 75 on the y-axis and I go across, there we go. So this point is 1575. The answer solved graphically is 15 hours.